three main categories: specification based, structure based, and the experience based. Without the test design techniques, you are creating a test case for this scenario. That is how you can integrate this coverage with your quality engineering practice. Hi fellow testers, so how are you doing? I hope you got a chance to go through our last couple of videos, especially the last one related to the test planning. Today also I am going to introduce you a new topic related to test design techniques. So this is the second phase in our test journey, because like when we get the new project or the new application, first we do the test planning and then we need to identify the test scenarios or the test cases. So to create these test cases, if you use test design techniques, it will allow you to create the optimal test cases or the optimal test data. So let's go to our topic today, test design techniques. So before jumping into test design techniques, first we need to understand like why these test design techniques are important. Can't we do our testing or test case writing or test designing without these test design techniques? I know like everyone have created at least one test case in their career. So at that time, did you use test case design techniques, or how did you derive the test cases? So before talking about test design techniques, we should have a clear idea like why these test design techniques are important. Otherwise, without knowing the purpose, there is no point in using these things. So if you can remember these two quotes from one of our previous videos, I mentioned that 100% test coverage is not possible, and also there is another one called the exhaustive testing is not possible. So these two means the same thing. It says like we can't test everything in our application. There are limits due to different reasons like the timeline, the deadlines we need to meet, the other resource issues, and then the limited resources we have, and based on all these things, we can't achieve 100% testing, because like we can't test everything. And also there is another quote saying there are no bug-free softwares. It's because we can't achieve 100% test coverage. But again, we are saying that we need to achieve the highest quality. Even though we can't achieve 100% test coverage, whatever we do, we need to utilize it correctly. Based on the time and the resources we have, we need to achieve the maximum. So that's why we need these test design techniques. So these test design techniques will allow you to create the optimum test cases and optimal test data. Using these things, even though you didn't test for the 100% coverage, still based on your coverage, you will be able to cover as much as possible. So that is why test design techniques are important. I hope now it's clear. With the purpose in mind, now we can go and check what are the different test design techniques we have. So I create a small graph here. Three main categories: specification based, structure based, and the experience based. The specification based ones are the black box testing. So if you can remember our video related to the testing types, there we discuss about the difference between the black box testing and the white box testing. So black box testing is the tester test the user flows without paying attention to the code behind it. But when it comes to the white box testing, the the person who create the test cases have a clear idea about the code behind it, and he write the test cases to test the code lines, not the user flows or the actual user behavior. So that is the difference between black box and white box. So if you missed that video, please go and check. There I gave a clear explanation based on the difference with some examples. So however, the specification based test design techniques can be used to create test cases for the black box testing type, and similarly structure based ones are for the white box testing. And then we have another type called the experience based. So under the specification based one, we have the boundary value analysis, equivalence partitioning, decision table testing, state transition diagram, and use case testing. So these different types of specification based test design techniques need to be applied at different levels. For example, like boundary value analysis and equivalence partitioning can be used to create test cases when you have a range, or if you are testing a range of values or input values related to range, that something like that. But the decision table testing can be used when you have multiple combinations. So if you need to test it based on different input combinations, like that. Then the state transition diagram, like based on the use activity, the application state changes. So in such a scenario, you can use a state transition diagrams. And then we have the use case testing. So I hope it's clear, like why we have these different types again under the specification base. So so you can't use the boundary value analysis for all the places at your application for test case writing, but you need to have a clear idea for which scenario which test design technique need to be applied to create the test cases. So this will be more clear when we walk through these different types, and I will explain it with some examples, so then it will be more clear to you. So then you know at which place you need to use what type of test design technique. So let's go to the first one. It's the equivalence partitioning. So before explain the equivalence partitioning, let's think about a scenario without the test design techniques. You are creating a test case for this scenario. So this application accepts values between 10 to 50. So any value below 10 is invalid, and again above 50 is invalid. Application will return error message. If you enter any value between 10 to 50, it will accept and give the success message and do the backend work. So without these test design techniques, if you try to test this one, maybe you will pick some random values because you can't test all the values, not even though all the possible values, because from 10 to 50 there are around 40 different scenarios are there. So with our limited time, we can't test everything. So we need to pick some random values and do the testing. So maybe let's say I pick three values, 20, 30 and 40, and I check for these three values. Okay, the application behaves correctly, but at the production level, so now we have an error because the user enters some value, some invalid value. User enters 5 and it fails. So the application fails. So that's because we test the values, all the three random values we pick are from a same category. So that's where equivalence partitioning can be used for your test design. So here this example, now you can see the bar chart here. So 10 to 50 are the valid values. So here I have partitioned this whole line, the number line, into three partitions. Anything below 10 is an invalid partition. Anything between 10 and 50 is a valid partition. And again, anything above 50 is another invalid partition. So here we have one valid partition and two invalid partitions. So in equivalence partitioning, what we do is like we pick random values from each partition. So last time without the test design techniques, we pick all three values and those were all from the valid partition, 20, 30 and 40. But this time, since we have a clear separation between each values, a clear partitioning, we have two invalid partitions and one valid partition. So I pick one from each partition. I will pick one value from the invalid partition, 5, then one from the valid partition, maybe 20, and one from the next invalid partition, maybe 60. So then it is more optimal, isn't it? Last time we covered only one scenario, only the valid scenario. Now we cover three different scenarios, two negative ones and one positive scenarios. This will test thoroughly your application and compare with the last time. So that's why equivalence partitioning need to be used for testing these type of range values. So the same behavior or the same approach you can apply for any other application where you test for some values where you have different ranges. Again, let's take another example. Let's say we have application where I register a user and his age should be between 18 to 55. Any user who is below 18 we can't register, and again any user above 55 we will not register the age. So again we can apply the same thing. So in that case the valid partition is 18 to 55, and there are two invalid partition, one less than 18 and this next one anything above 55. So we can pick one value from each partition, one or two values, and then you can test. And here in under the equivalence partitioning, when we do the testing, we make an assumption. That is like we assume all the values within one partition will behave in the same way. That means like if you pick multiple values from the valid partition in this particular example, 20, 30, 40. So we believe or we assume that all these values will behave in the same way. So in that case, we will not test all the values between 10 to 50. Instead, we pick some random values from this partition and test. So that's why we pick one or two values from each partition only and not all the values. Since we have the partitioning and we believe or we assume all the values in this partition behaves one way, all the values in this partition behaves another way, and all the values in this partition behave again similarly based on the invalid partition. So that's how the equivalence partitioning will work. Hope it's clear to you. So next go to the next type, which is known as the boundary value analysis. So boundary value analysis will go with the equivalence partition. So you can see the same number line I have here, two invalid partition and the valid partition, and the boundary. So boundary means like when we separate the partitions at the margin where the two partitions will connect. So that is the boundary. So in that case, we have one boundary here and another boundary at 50. In boundary, so in the equivalence partitioning, I said you need to pick multiple or one value or couple of values from each partition randomly. But here in boundary value analysis, it gives a more proper approach saying which random values you need to pick. It says you need to pick values at the boundary because the most of the time these boundary values are more error prone in our application. For an example, let's say the code is written with if else statement. So it will check if value is greater than 10 or less than 50, do something likewise. So if we pass this boundary value 10, then application will check the condition 10 is greater than likewise. So there can be two different scenarios. One is less than scenario and greater than scenario and greater than or equal. So that are two different things, isn't it? So our expected behavior was less than or equal scenario. Then 10 should be in the valid partition. But let's say developer made a mistake and he put only the greater than sign, not the greater than sign, not the equal. So in that case, 10 will fail because now 10 will fall under the invalid partition. So that is why we need to test for the boundary values. So that is one simple example. So there can be other scenarios like that too. So that's why in the boundary value analysis, it says you need to pick those random, not the random values from each partition, but from each partition, but try to pick value from the boundary. So here the boundary is 10 and also pick the lower and the upper bounds of the boundary. That means 9, 10 minus 1 and 10 plus 1. That means, so here we need to test for 9, 10 and 11. So here we will test for 49, 50 and 51. And also if you need, you can pick one random value from each partition as well. So we will test for 9, 10, 11, 20, 49, 50, 51 and maybe 65 likewise you can pick. So you need to make sure that you test these three values definitely. The boundary value and the lower and the upper bounds of the boundary. So because those are the more error prone areas. So I hope now it's more clear. So equivalence partitioning and boundary value analysis you can use in conjunction too when you do your test designing. Okay. So next jump to the next one. So I hope it's clear like the last two, the boundary value equivalence partitioning you need to use with the numbers where you input and some range. But what about, but that's not only the scenarios available on our applications, isn't it? So there are different other scenarios too, like different inputs you can input with multiple combinations, different combinations. So in such a scenario, you can't use the previous two types. So for these different combination, different input combinations and based on the input combination, if the output is differing, so in that case, you need to use the decision table. So in decision table, what we do is like, we will list down all the inputs and then we try to identify different combinations of each input and based on those combinations, how the output will differ. So this is also known as the cause effect graph too, because cause is the input and effect is the output. Cause effect means how the output will behave based on different input combinations. So here you can simply create a small table and when identifying this number of combinations, so there's a small equation 2 to the power n. So that means if you have two inputs, so n is 2. 2 to the power 2 is 4. If you have only 2 inputs, that means there are 4 combinations. Similarly, if you have 5 inputs, that means 2 to the power 5. That means 32 combinations, input combinations. So that's why we need to create something like this, a table, because otherwise, like if you have 32 combination and if you didn't create a table like this and you just start testing or write test cases, there is a high chance where you will miss couple of combinations, isn't it? Because it's very hard to remember like all the 32 combinations in mind and whether we executed that combination or not. But if you have a table like this, now it is very easy. You can go column by column for each combination. So when we have like very small number of inputs like this, it is easy to do manually. But the example I mentioned, like if you have like 5 inputs, then 32 combinations, it's a bit hard. However, so this is how the table you can create. Here I have added the different inputs. So this is a login scenario. So in that case, we have only 2 inputs, the username and the password. And then here, this row is for the output. We will check this, and then these columns are for different combinations. So as I mentioned, we have only 2 inputs. That means n is 2. So 2 to the power 2 means 4. In that case, we have 4 different combinations, 4 columns in the table. And then if username is correct, there are like different scenarios. For username, you can put the incorrect username or username empty, and also username correct scenario. So those invalid scenarios, the notation will be if like we fill the truth table, we can use true and false. So the negative scenarios, we will the notation will be if, and for the correct scenarios or the valid scenarios, the notation will be t. So this scenario, this combination, that means username incorrect and password incorrect. So it's obvious the output should fail. So the login failed. Next one, username incorrect, password correct. Again, output is login failed. Username correct, password incorrect. Output is login failed. The last one, so all these 3 combinations are negative scenarios, and the last one, the positive scenario, the positive test case, the username correct, password correct. So in that case, login passed. So this is how you can create a decision table or a cause effect graph for your test design. I hope it's more clear. So now each column, each combination can be taken as a test case or as test data for the test in these different scenarios. So now it is very easy for you to track which combination was executed and what was the expected result and which was not executed. So you can follow it very easily. So that is why we need to use decision table test designing technique when you have multiple combinations to test. The next one is known as state transition diagram. So when you see this particular diagram, I am pretty sure that you will remember the activity diagrams you have created at your university or while you do software designing, isn't it? So this is similar to the activity diagram. So in the activity diagram or the state transition diagram, what we show is like how how different states of application change based on different use actions. So this is an example of a login scenario again, where user will be prompted to enter the PIN. But if he fails to enter, he will be re-prompted. Likewise, he will be re-prompted 3 times. So he get 3 attempts, and if all 3 attempts he fails, his account will be blocked. And if he enter the PIN successfully in one of these 3 attempts, then he get access to the application. So at the initial stage, so this is the initial state of our application. Then user will be prompted to enter the PIN. And these are use activities. So based on these use activities, you can see how application state changes. So if he enters correct PIN at any of these 3 attempts, then access will be granted. And if he enters the incorrect PIN, again he will re-prompted. Third time he again re-prompted. And here again if he enters the incorrect PIN, his account will be blocked. So these are the different states of the application. So this is also again a very small example because we have only 2 states and 3 or 4 use activities. But again, imagine if we have multiple use activities and multiple states, it's very hard to track those state changes and everything without a diagram. But since we have this diagram, now you can see the big picture from here. So not only for test designing, you can use this for brainstorming with your team as well. maybe even at the requirement designing stage, requirement stages. So if you have this diagram, now all the BAs and the devs and the QAs, everyone can do brainstorming, and if there are any requirement mismatches or if you have missed anything at the requirement level, now easily you can identify that from this particular diagram even before you start your testing, isn't it? Because like if you have missed this, the third scenario, and how the count state should be changed to the block, so from the diagram that will be captured, so no need to start testing or the requirement level issues, you can directly identify through these diagrams. And again, now let's see how you can derive the test cases through this diagram. So so this is one flow. So user started and was prompted to enter the pin, and he entered the correct pin and access granted. So that is one test case. That one user flow from the initial stage to the end stage. Then this flow, enter pin, incorrect pin, enter pin, and correct pin. So that is the second test case. Enter in correct pin at the second flow. Then in prompted first time incorrect, second time incorrect, and then third time correct. So that is the third test case. Then start first time incorrect, second time incorrect, and third time also incorrect pin, and account gets blocked. So that is the fourth test case. So we can derive 4 test cases using this state transition diagram. So again, if you didn't have this diagram and if you just go to the application and try to test, then there's a high chance where you will miss a couple of scenarios. Yeah, maybe you will check definitely you will check the correct pin scenario and the account blocked scenario. Those two you will definitely check. But there is a high chance where you will miss these 2 scenarios. Correct pin at the second prompt and the correct pin at the third prompt. Those are like, there's a high chance to miss those. But if you have this state transition diagram with you, and if you have derived the test cases from this, now you have a separate test case for each user activity. So that is how state transition diagrams can be used for your test design. I hope now it's clear. Then we have the use case testing. So this is more or less like the same thing like what we do actually, even though we didn't know that we are following a test design technique. Because like when we do testing, if you are following agile methodology, so you will get the stories. A story will have something like, as authorized user, I should be able to log into system with the correct code. So that is one story, and it will have the acceptance criteria, isn't it? And also, if you are following the waterfall methodology, you will get the SRS document, and it will have the requirements like this. As a user, account should be blocked after 3 attempts, likewise. So these are user flows, or the use cases. So we test for these scenarios, the user flows, as I explained in the previous scenario also. So we can check the successful login by checking the use case. Then the unsuccessful login or the account blocked state, those things you can check by following these use cases. So that is very simple. You need to check the use case or the user flows, actual user flows as the user. So we came to an end for the black box test design techniques. I hope those things are more clear, because the black box testing, as I mentioned, we do on the user application without having any knowledge about the behind code. So all these things you saw, we check on the application level, not on the code level, the UI level or the user flows and the user activities test. So that's why these are falls under the black box test design techniques. Then we have the white box test design techniques. Under white box, these things also I have already explained to you under the testing types video. Please have a look if you missed that one. But again, I will walk you through. So this statement testing is the first one. So I hope you know what is a statement in your code, or statement is a line of code, or the LOC. LOC is the shorthand form for the line of code. So here in this example, I have a small method which will return the sum of the inputted values. So this will take 2 inputs, 2 integers, a and b, and also it will return another integer, the sum of the 2 input values. So very small method, and it has 4 lines of codes if you check. So this is the first line, then the second line where we do the actual mathematical calculation, and the third line is for returning the sum, and the fourth line the method close statement. So these 4 lines are the 4 statements of this code. But imagine this is just one small method. But actually in your application you will see thousands of methods like this and hundreds of classes like this. So just imagine how much of statements will be there, the line of code. So then here is one such example for a statement testing. Using JUnit framework, I have created a small unit testing to test this particular method. So we are doing the assertion here. We are checking whether the return value when calling this method, the return value is equal to 15 or not, because we are passing two values 5 and 10. Even if you do the calculation manually, 5 plus 10 is 15. So if the method behaves correctly, it should return 15, and we are expecting this is our expected outcome. Here it should return 15, and if it is the method works correctly, so the assert should pass. So if you check, this is how you can create a simple unit test for the statement testing. Then let's say we call this method sum 5 pass and 10 is passed. So then it will execute or exercise the first line of code. Then it will go to the second line. It will also be executed, and the output will be stored in the C, and then it will return the C. So third line is also executed, and fourth line will also be executed. So in this simple scenario, using our test case, we were able to exercise or execute all 4 lines of our of code, all 4 statements of our code. So that is statement testing and the coverage. I will explain more about the coverage at later, but this is how the statement testing will be done. But again, now think if we have multiple methods now, then maybe there is another method for the subtraction, multiplication likewise. So only this, if you have only this test case, it will cover only these 4 statements or only this method. Then what about the other methods? Then you need to create more test cases to cover those as well. So then you need to have a clear idea about your code and about the coverage and how you can achieve the statement testing. I hope this is clear. It's very simple. Next, similar to the statement testing, now we have decision testing. Decision testing will involve with decision making. If you have if else switch statements, then where we make some decisions based on the input values or based on the other internal calculations or anything. Right? For example, here, so the same method, I just added some extra part, this if else part here. So the same, we take the sum and assign it to in a variable called C, and we check whether the variable is greater than 10 or not. If it is greater than 10, we will return this message calling greater than 10, or else if it is less than 10, we say it's less than 10. Same JUnit test again, and we are passing the same values sum 5 and 10, and we check this time whether it will return this particular message. So if we pass sum 5 and 10, 5 plus 10 is 15. It's C. That means it will go to here. Now it will do the decision making. C is 15. 15 is greater than 10. Then it should return the message greater than 10. But here we have asserted for less than 10. So this is one example of a wrong test case. So that also there can be issues with application and also maybe with your data and also maybe with your test case as well. So then you need to clearly identify, or when you debug, you need to identify where the actual error is, whether it's an actual application issue or whether it's related to your test data you use, some improper test data, or whether the test case is errorsome. So you need to have a clear idea on that. You need to properly identify what the actual error, whether it's actually the error on the code or the backend code or the testing code, QE code. So here we have the error here. So the actual message should be greater than 10. However, okay, now let's jump back to the decision testing. So here now you can see let's check the statements which were exercised. So statement 1 was exercised, statement 2 was done, statement 3 was done, statement 4 was also exercised, and then it went to statement 5, and then it jumped here to return. it didn't exercise or executed these three statements. So that is why you need another test case to cover or exercise these three statements. Now I hope it's more clear. So in this case, since we have two branches, if C is greater than 10 or if C is less than 10, based on the branch, it will do something different. Using one single test case, you won't be able to cover these two scenarios because the decision every time will take you through only one path. You can't go on the second branch using the same input. So that's why you need to have two test cases. Maybe next time we will pass some 3 and 2. Now it's 5. Its C is less than 10. In that case, now it will go through the else branch, the second branch. So since here you have two branches, you need to have at least two test cases to cover all the decisions, all the branches and all the statements as well. So I hope now it's more clear to you. Now let's go to the third one, the condition testing. Condition testing is here under the conditional coverage, we check the conditional statements or the logical expression. So here you can see logical. So there are two decisions, whether C is greater than 10 or C is less than 20. We are checking. And here, using the AND operator, we have combined those two operators, the decisions. This is a condition statement for a logical expression. So these scenarios you need to test as well. So that is where condition testing will come into play. So I hope now it's clear since we have covered the two different parts previously. So the same thing. And then there is another. So one important thing here is under conditional testing, we will check the individual outcomes. Individual outcomes for each logical expression for the condition. Then there is another thing called the multiple condition testing. It's the more advanced version of the condition testing. Condition testing, we check for the individual outcomes, but in the multiple condition testing, we check for the different combinations of outcomes. So I hope it's more clear to you now. So next I have the coverages. So before talking about coverage, I will take you back to the last video. Under test planning, if you can remember, I mentioned in the test plan, we can add a section called the exit criteria. Exit criteria will define at which place you need to stop testing. You can consider the testing is done. So under the exit criteria, I mentioned that we can add maybe no critical bugs are open, all the reported issues are fixed, the automation coverage is 80%. Likewise, we can add some checks. So if these checks are passed, so then we can consider or we can make the decision to go to the next stage. So similarly, you can add these statements or this statement coverage, decision coverage or conditional coverage as well to the exit criteria. So for example, let's say in our example, in our second example, if we pass this particular values, 5 and 10 I mentioned, it will go only through the first part, the first branch, and it won't go through the second branch. So that means if we check this statement, there are 3, 6, 7, 8, 9, 10, total 10 statements, and it will not exercise these 3. So that means it will execute 7 statements out of 10. That means 7 divided by 10 into 100%, that is 70%. So our statement coverage is 70%. Number of statements executed, we need to divide from the total number of statements and then we take the percentage. Similarly, decision coverage. So in that example, so we executed or we exercised only through one branch. The second branch was not exercised. So that means number of decision outcomes exercised 1 divide by 2 total number. That means 50%. So the statement coverage was 70% and the decision coverage was 50%. So we can add these things into our exit criteria. Maybe we can define as the statement coverage should be 80% under the exit criteria in the test plan. So in this case, since now our statement coverage is 70%, we can't consider this as done. We need to increase our statement coverage. So we will create another unit test now to go through the second branch. Now 10 out of 10. So we have 100% statement coverage plus 100% decision coverage. So I hope now it's more clear to you how this coverage is taken and how it is calculated, and how you can increase your statement coverage, decision coverage, and those things. But don't worry, there's no need for you to do these things manually, because now almost all the IDEs supports the coverage. It will allow you to check the statement coverage, decision coverage directly. And also there are other third-party plugins, and also there are other plugins where you can integrate with Jenkins. So when you push your code, and it will run the checks, and it will give you the coverage, and from there also you can mark it as failed or passed. So then the developer knows that now he need to increase the coverage in order to get the build successful. So that is how you can integrate this coverage with your quality engineering practice. Okay, now we discussed about the multiple condition testing as well. I mentioned that under condition testing we check for the individual outcomes, and from with the multiple condition test it's the more advanced version where we check for different combinations of outputs. Then we have the all path testing, or the all path coverage. Here we try to analyze all the paths, all the code pathways in our code. So we need to assure that all program routes are exercised or executed using our unit tests. So then that's all about the whitebox test design techniques. And the last one we have is the experience-based testing. So from the name also you can see experience-based. So these test design techniques will work with the user experience or the quality engineer's experience. The person who create the test cases, the experience of that particular person. For example, let's take I am currently working on an e-commerce application. Previously, I have already worked on a couple of e-commerce applications in my maybe in my last organization, or maybe in my last project, could be anything. So now when I start to create test cases for this particular application, since I have already previously worked in similar application, I know where we face so many issues, which areas we had more troubles, which components. For example, payment gateway integration had a lot of troubles last time. So now this time I know I need to test it thoroughly. I need to have more test cases for payment gateway related scenarios, maybe email sending. And also, if you can remember, in one of previous videos we discussed that why we need to group these bugs, and then from that how can we identify the different components where we need to test thoroughly, and those things, those stats why we need. So this is another example here. So if you have those information with you from your last project, so you see 50% of bugs were related to the payment gateway. Now you know you need to test it thoroughly. And also you can take the stats related to the production bugs too. 20% of production bugs reported were related to the email functionality. So now you know this time you need to test it thoroughly. So that is where experience of the quality engineer comes into play. So that is known as the error guessing technique based on the user's experience. So with your journey goes through, and when you get more experiences in this quality engineering practice, your error guessing skills will be high, since you have more experience and you have seen more issues and you have seen the places where it fails. With all this in your mind, you can create good test cases with your error guessing skills. The next one is the exploratory testing. This also we have already discussed on the testing types. So exploratory testing means without following a proper test case or written test cases, we just go to the application and go and do execute some user flows, different user actions or activities, and then see the output. So this is a good candidate to execute at the end of your cycles. First, you start testing based on following your written test cases, test plans. Then you report bugs. Then you get the bug fix cycle. Again, you follow those. Then you create the automation test cases and run those things. And if you can remember the pesticide paradox, which means there is no point of running over and over the same test cases because it won't find new issues. So you need to update your test cases. So this is similarly at the end. So after you complete all your testing cycles, and let's say if you have more time, then maybe you can give a try with the exploratory testing. So without following your written test plan, you just go there and try to execute different user flows and do some different user activities in order to identify some issues. So the exploratory testing, either you can do it by yourself or some other project members also can help. And also if you can get some people from some other projects who doesn't have previous experience or who doesn't have worked in this particular application, so then they are like more similar to actual production users, so the ones who first time trying to touch this, so similar to the alpha testing or the beta testing we discussed. So likewise, then these people will try to exercise different activities on the application and try to break your application, and then it will allow you to identify some hidden bugs which were hidden previously. So that is where the experience based techniques you can use for your test design. So that's it for the test design techniques. I hope now it's more clear, and I hope you will use these test designing techniques next time when you create your test cases. And then maybe you can compare the results, how you derive the test cases previously versus how you derive the test cases using these test design techniques. Now you can see whether is there any improvement in your process, and whether you will be able to identify more issues with these optimal test cases and the test data. So you can do a self evaluation, and then you can identify the improvements and anything else to be improved. So I hope all things are clear, and if you have any questions still, don't hesitate to reach out to me. So you can either use the comment section here, or else you can drop an email at qvbro.pro@gmail.com. I'm always there to help you guys with all your queries. So I think we can end the today's video from here, and I will come again to see you with another interesting topic. So stay in touch and happy testing till then. See you.